Okay, hello everyone. Welcome to the analysis meeting on March 29th, 2022. Hope you're all having a wonderful day so far. On our agenda for today, we'll have our usual check-in and another OpenRocket file update, thanks to some updated weights that we found out. And then because of this, it's kind of a new project that's kind of urgent. So we'll talk about that. And then just wanted to see if there are any other updates with the centering ring and bolts FEA. I'm going to talk about the new Roxen file, Charlie's OpenRocket intro project, and then just an overall project progress check, and then finishing it off with any questions you guys have. So the check-in, just the usual, any recent task progress you've made, or in particular, any obstacles you faced, whether that's technical or just things that you've encountered, or anything you may have questions on.
Yeah, I'll go first. All right, so I've honestly the progress I've made on the FEA has been kind of slow, and that's just my fault. I've been busy with some other things, but I did discover that because Gustavo sent me the centering rings as an already made assembly, I can measure, the hole distances that he made, but it's not like an exact value. And in order to pin, everything together, is like they need to be perfectly concentric. And so I guess right now I'm just gonna have to remove that assembly from the FEA model that I have right now and just make my own centering rings and just put them in so they're, so the holes are concentric.
Yeah,
and that's pretty much it.
Yeah, I think that's the best course of action, because I don't want to rely on Gustavo just to CAD a centering ring just so we can input it.
Yeah. No, I mean, it's pretty simple. Yeah, I got it. All right.
Cool. Thank you.
Yeah, I guess I could follow that up. So I've been thinking a decent amount on especially the centering ring situation. I think we can probably get away with hand calcs in regard to the number and type of screws, machine screws or bolts, whatever we end up using for the centering rings. I think hand calcs would be a lot more accurate, just because, I mean, we've kind of done it before, and Gustavo already made a calculator that was pretty similar to the way I calculated how many screws we needed for my capstone. So in that regard, I think that's what we could kind of go with, in my opinion. And then in regard to the centering rings themselves, just like right off the bat, I would feel a lot more comfortable using aluminum, which I know that ends up adding more weight, and that's like a whole nother thing. So if that's possible, that's what I would say. Because when I ran just like the initial FEA with the thrust load on it, not even the landing load, the plywood material properties, they did not last up to like 1,000 pounds of force. I'll definitely rerun that and double check it. But that's what I think. I think we could probably play it safe and do aluminum rather than do wood. But of course, if that's not possible, we will have to think of another alternative. That's pretty much it.
What do you think about fiberglass instead of aluminum?
I would definitely, I would definitely prefer that over. I would prefer anything over wood, to be honest. It's just for fiberglass. Same thing. Material properties are always the issue when trying to find or run it. So I wouldn't be too reliable on giving an accurate simulation if we do that. But I would definitely feel like that's definitely stronger than wood. So
I don't know if you or Arturo have looked much into it, but I know G10 fiberglass, like the sheet kind, should be not as complicated as G12 or just like the individual fibers. But don't quote me on that. I'm not too sure. But I don't know if you've looked into material properties of G10 versus G12.
Yeah, that does sound familiar. I'll look back and I'll double check that. Yeah.
Yeah, I'll look into it. Sure.
Could you send me that analysis you did, um, Omar? The one with the wooden centering rings. Just want to have a look at it.
Yes. Well, are you
Okay,
gonna be at
cool.
lab tomorrow, by the way, or no?
No, not tomorrow.
Okay. All good.
Yeah.
Sure. Anyone else? We'll move on to our first order of business, the Open Rocket file. So on Monday, I was in the lab with Recovery, and I was able to work with them to update the components, or all of their components and their weights, and also just get a more accurate location as to each of their shock cords, parachutes, and connections to the bulkhead. So those are all updated now. Special thanks to Carlos and Titus for that. But our new projected statistics give us a stability of 1.21 calibers. This is just completely raw, so without adding a weight to the tip of the nose cone to compensate for it, but it's pretty low. And this is also with inaccurate weights for that motor sleeve, boat tail, centering ring, that whole assembly. But I'm projecting that more accurate weights should push the CG back, which will further lower our stability. I think that because right now they're set up as plywood centering rings, and as we were just talking, I doubt that we're going to go with plywood. So that's just going to add more weight on the wrong side of the center of gravity, which is not helpful for us. But this is what the Open Rocket looks like with everything updated. It does give us a pretty good apogee. I think this is with airfoiled fins of just under 29,000 feet. But yeah, we're no way they're going to let us fly with the stability that low. So some things that I've thought of to try and increase stability, and that I've talked about with the leads and Gustavo, is obviously the popular one of adding weight to the nose cone, and just because it's the furthest leftmost point on the rocket to shift our CG to the left and increase stability. I also thought about maybe adding weight to the avionics tray, which now looking at that, I'm not sure if it's the best idea, because if we are going to add weight, we want to add as little weight as possible, or as just pretty much how much weight is required to give us a good stability. And it's most effective to add weight to the top of the nose cone instead of just to the avionics tray. Another thing that I know I don't want to do, and I'm sure y'all don't want to do either, is looking back at the fins and maybe trying to increase the surface area. The major issue with this is that we did already order the carbon fiber sheets. So we are limited to kind of what that total area is. I think it's 500 by 600 millimeters. And I'm pretty sure these already take up a good amount of space. So trying to increase the surface area on these would be pretty tough, and also keeping that in accordance with the divergence and flutter calculations. So I feel like that would just open up a whole other can of worms. So yeah, I think the two most viable options we have is adding weight to the nose cone and then also increasing the airframe lengths. Previously, we had the lower airframe to be at 50 inches long and the upper to be at 25 inches. If we increase the lower airframe to 60 inches and then add 1 pound to the tip of the nose cone, that shoots our stability up to 1.58 and drops our apogee by roughly 1,000 feet to 27.5. So I think this could work, but I think once again, once this motor block, these centering rings, and the motor sleeve weights get updated, I have a feeling it's just going to push it back down or not help us out that much. So because of that, I would like for the validation team to try and optimize Zenith's design given some fixed constraints. These are the ones I've thought of so far. There's definitely more, but yeah, trying to keep the fin shape and material the same, the max size of the upper and lower airframe. I believe the airframes that we bought is 60 inches for the lower and 36 for the upper. I can confirm that and send it in the Discord later on as well. But the dimensions and locations of the avionics and payload bays should stay the same. Obviously, the recovery components and their location should stay the same. The motor sleeve, boat tail, and centering ring assembly is kind of the major wild card here because it's something we're still unsure about. But I think if we could try and maybe assume worst case scenario and go for aluminum centering rings, kind of just a heavy motor sleeve, and I guess just overestimating on all of these components and then trying to validate, that may be the best way to do it. So I guess Amy, Will, and Charlie, if you could shift your focus to that. I would like this to be done ASAP, but I know it's kind of contingent on a bunch of other things. So just the more work we can get done, the sooner, the better.
I have a question.
Yes, sir.
So what are the unfixed constraints? Weight and nose cone. Is that it? Or weight, essentially?
Yeah, I think the most effective things that I think would help us would be adding weight to the nose cone and increasing the airframe lengths. I don't want to increase the airframe lengths too much because I think if we go with the full length lower and a full length upper, our stability shakes out to be better, but our apogee is a lot lower because we're just increasing our surface area and then increasing drag. So there's like a fine gray area of the spot where we want to be, where our stability is good, but our drag isn't that bad.
We can't mess with fins.
You can if you keep it within the carbon fiber sheet dimensions.
Which is
500 by 600 millimeters. But
okay.
let me confirm that before you start.
We should have confirmed all the weights before we.
Yeah, that was definitely my mistake. Yeah, I really regret not confirming it before.
Yeah, but I think we'll be good with the you said 500 by 600 or wait,
Yeah.
what did you say?
Mm-hmm.
Okay.
I have
Okay,
also a question. I know there's a lot of open rockets on the drive, and it's hard to sometimes tell which one is the most recent one that we need to be working with. And I'm looking at the analysis drive. Is the one that says Zenith R mod or the one that says Zenith R, the one that is the most recent?
The one that you see with the stability of 1.21 should be Zenith R mod on the front page.
So the Zenith R, right? That regular one is that's not the most updated one.
No, it should be the R mod.
Okay.
Yeah, I think we're gonna leave just the most up-to-date open rocket just on that front page, just so you don't have to go down the rabbit hole of 30 different folders to try and find it. Cool. This we kind of talked about in the check-in, thanks to Omar and Arturo, but something I did want to add is just if we could maybe finish by the end of the week, wanted to see what your thoughts on that was, if that's possible, or if that's pushing it, just considering your personal schedules.
I think that's a good deadline to have. I feel like we should probably push ourselves a little bit anyways to actually get it done.
Yeah, I've honestly been slacking a little bit on this. Yeah, end of the week, that should be fine.
Perfect. I will try and see if Gustavo can come into lab tomorrow, but I'm not sure if he'll be able to. So maybe setting up a meeting with him after we finish our stuff, just to talk about final material and then maybe dimensions of these centering rings as well. Thank you guys for that. Brief update on the Roxim file. As you know, we're trying to shift everything over to Roxim, but if you could name a more iconic duo than analysis and software issues, I'd love to hear it, because we had trouble verifying the product key on the lab computer for Roxim. There is a workaround that Will and I tried on Monday, but it did not work for us. So there's no guarantee that we can get Roxim back on that computer. Thankfully, I do have a copy on my personal computer, so I'll just take care of this and transfer the OpenRocket file onto Roxim, and then let you guys know what the results are once I get them. Yeah, screw Roxim. Okay, Charlie, this is mainly for you. I just wanted to formally define kind of what I told you in the lab last Wednesday, but wanted you to get your feet wet with OpenRocket and all the different facets and components of the software. So I think the best way to do that is kind of what we did way back when. I think it was like late July for like the original analysis team. We're building a rocket in OpenRocket to get as close to 30K as possible. Absolutely no restrictions using material, motor, and shape and number. These are the three main things I want you to think about. First and most importantly, as you're kind of seeing with our design now, stability. So what are the factors that affect center of gravity and center of pressure? And then once you have a stability, how does that stability impact flight performance? And if you remember that link that I sent, or I linked it on like the first slide of the first meeting you came to, it was like a giant website with a bunch of different documentation and information about rocketry. That should have a good amount of stuff regarding stability if you're interested in learning more about that. Then consequently, what aspects of design are useful for increasing apogee, and generally just what works well and what doesn't for rocket design. So I know you sent me kind of your first attempt before this, but if you could present your rocket and kind of what you learned considering these questions at next week's meeting, that would be great. And I'm sure we'd all love to see your design and what you've come up with. And then obviously feel free to ask questions. I think especially the validation team has looked at or has logged a lot of hours on OpenRocket. So we're all here to help.
Okay, cool. Yeah, yeah, I'll definitely look into the stability aspect because I'm not really sure what what the goal is in terms of stability.
Yeah,
Number
and
one.
I think you'll find that no one really knows. There isn't kind of a set standard of stability. It's very dependent on, I guess, like what rocket you're launching, what your goal is with the rocket, different things. But Spaceport defines it between 1.5 and 2 calipers. That's helpful.
Cool. Yeah, I'll work on that. Thanks.
Thank you. And then if you do finish that early, I'll make the slides for next week's meeting as soon as possible. And then you can kind of make your slide for that and then go to help Will and Amy with the OpenRocket and actually trying to work on Zenith's design. That's good. Okay, just a general project progress check from the stuff I outlined, I think at the beginning of spring break. But wanted to see if there is any progress being made on any of these fronts in general. I know right now they're maybe not the most important, but wanted to see what y'all have been doing.
For the questions, I haven't even touched it yet. For Roxham Zenith file, there's one in the computer, but we can't access it. That's going good.
I think that we may have, or I may have tried to get us to answer these questions a little too early. So I think instead what could be helpful is try and actually think about the questions we need to answer. So maybe looking at some of what the design team is doing with CFT or FEA, or the stuff we've done in the past with the nose cone, and come up with questions, maybe something like, why'd you choose this nose cone? Or trying to provide also a quantitative reason, and not just, oh, it was the best performing. Things like that I think could be useful, so that when we actually go to answer them, we have a set of actual questions other than kind of the jumble of stuff that's there right now.
Yep, I like that.
So I have some updates, I guess. This wasn't directly assigned to me. However, due to capstone, my needs in my capstone project, I took it upon myself to learn ANSYS, and I was doing some CFD on Zenith and some other stuff. And I got some pretty cool results from that. I don't know if Nico had done this before, but the drag forces that I was getting were a little higher than OpenRocket. They were showing 1,334 newtons instead of like the 970 something newtons. So I don't know if that really changes much, honestly, but it's pretty cool that we have now like I also have like values for like pressure drag and viscous drag and like where they act and stuff. So I could drop that in Drive if we have like a location for that.
Yeah, I don't think Nico or Prith have uploaded their results to the Drive yet, but you can make a new folder and drop it there. That would be super helpful. And then I don't know if Nikolai, you were interested in taking on the recovery CAD for the bulkhead. I guess the next time you're able to make it to lab, I can show you the physical parts of what we need to CAD for recovery.
Yeah, I could do that. Do we have another lab time this week?
We do tomorrow, 6 to 8, but I was going to talk about that next. I don't think I can be there, so I think I'll do the same as a few Mondays ago, or last Monday. And if Omar could be there and open it up for y'all.
I could come there tomorrow, but then you wouldn't be there to show me like what I need to CAD.
Would you, sorry, I'm talking to Carlos. Would you be able to be at lab tomorrow at 6?
6 a.m.
p.m.
Yes, I'll be there 6 p.m.
Or anytime between 6 and 8. Sure. Okay. Cool. Yeah, just to show Nikolai what's going on with what you need to be done. Cool. Okay, Carlos can be there, so he can show you what's going on with that.
All right, I'll be there.
Perfect. Thank you, sir. I think that covers it. Yeah, I will not be able to be in lab tomorrow due to FEM raining hell upon me. But any questions from anyone about anything today?
Yeah, not really a question, more of, I guess, a comment.
Mhm.
I guess this more relates to like new stuff like the motor sleeve, centering rings, all that stuff. The CAD
Yes.
files in particular. Um, I think there was a lot of confusion on who has, I guess, the final CAD file, or if it's our responsibility to make that. So I guess just wanted confirmation on what is whose responsibility or what's been created, because I made the centering ring one based off the motor sleeve dimensions that I saw in the sub-team needs. But I don't know if that's already been catted too, or if that's also up to us or anything like that.
I think it's best to just CAD everything for us because I don't think Gustavo's CAD is the most accurate. I think he made his just for like a visual representation. So if we're actually
Okay.
going to try and make an updated CAD and run an analysis on it, then I think we'd be better off just making it.
All right,
I think
so-
the CAD that we use for the FEA is going to be the most accurate. So I
Yeah.
mean, if you have to CAD your own parts, then that'll be it.
all right.
Yeah, I think we can. I mean, we know the dimensions of the motor sleeve and the boat tail roughly.
Do we know the like the length of the motor sleeve? I know we know the diameter, OD and
It
ID.
should
but-
be. It should be the motor. It should be the O34 length minus an inch.
Okay.
Because I think what we have in the lab is longer than that, so we can just cut it down to conform to that.
I have a quick question.
Yep.
So is there any final decision on how the lower airframe and the boat tail and the fins are gonna attach? Because I mean, I've been hearing different ideas being tossed around.
Yeah, I think the most likely option at this point is kind of what we have set up with this and the 3 centering rings, the motor block, and then Gustavo's idea for the motor sleeve and fin connection was to buy carbon fiber cloths and do pretty much just like fillets of epoxy.
Yeah,
that will,
yeah, that's what he told me too. Okay, all right. Yeah, just want confirmation on that.
Yeah.
Okay, all right. If Carlos is there, can I ask him if he got everything he needs for that surface area equation he was asking for?
Oh yeah, sure. We'll disconnect.
Hey, Arturo has a question for you. What?
Oh, hey, what's up? I was just asking if you got everything you need for that equation for
Yeah,
the surface area. Yeah.
yeah. I think I was talking with Christian, who's a recovery member, who was the one that worked on the other 2 sections. And
Mhm.
based on the results that we got from those formulas, it looks like we can use it, but I'll bring it up in the general meeting today because he said he didn't trust his own work, and he wanted to give everybody else in the team, I guess, a final chance to work on it. So I'll bring it up in the general meeting to see if anybody else wants to give it another go. But
Gotcha. All right. Yeah, I mean, just keep in mind that that is kind of a more generalized equation, so there is going to be a certain degree of error.
Yeah, right. I mean, I think for our purposes, like since like we're not actually like launching like an actual rocket, I think it's gonna work just fine.
Yeah. Alrighty, sounds good.
All right, thank you.
If there's no more questions, then you're free to go. Thank you for stopping by. Hope to see you virtually in 20 minutes or so at the general meeting.
Bye, everybody.
Bye.
Yeah.